In this section, we will define common and natural logarithms, define the change of base formula, and solve the simpler logarithmic equations. All logarithms have a base associated with them. If a number is not subscripted, we assume a base of 10. We refer to the base 10 log as common logarithms. When we see natural log of x, this is the natural logarithm. The base associated with natural log is e. E is a constant, irrational number. Since it is an irrational number, as a decimal, it goes on forever with no pattern. To use e in computation, pick up the value on your calculator. You should have an e key on that scientific calculator. On scientific calculators, there should be a common log and a natural log key. Above each of these keys, you will find their inverse, the exponential function. Referring to these keys, it will remind you what the bases are associated with these two different logarithms. You can always refer to the function above those keys. All scientific calculators have a common log and a natural log function. If you are asked to find the value of a logarithm with some other base, we will need to work through the change of base formula. Try the first two on your calculator. You need to make sure you know how this needs to be put on your calculator, since some calculators require you to hit the log key first and then type in the argument, while others work the other way around. As for the third example, we're going to need the change of base formula. The change of base formula says we can change to any base we want to, but if we're going to need to use that calculator, we will need to change to common or the natural log. The change of base formula is fairly easy to understand. When you use the change of base formula, take the argument of what you are changing from and place it as the argument of the factor in the numerator. The base, which is always lower or subscripted, is the argument of what you have in the denominator. We changed the base of log base 5 of 11 so that we can find its value. We can change again to any base we want to. I am changing to base 10 and e just to show you that you will get the same value. Verify this on your calculator. With the way log base 5 of 11 is written, the 11 is higher than the 5. The 11 is the argument of the numerator and the 5 is the argument of the denominator. When you take this to your calculator, the result is approximately 1.49. If your calculator brings up parentheses on the log function, make sure to close, otherwise your calculator will be closing at the end of the line that you're typing in. Here are a couple of fairly simple logarithmic equations to solve. The reason why I refer to these as fairly simple log equations is that there is only one log term. We will consider equations with more than one log term in the last section. The way we solve logarithmic equations is we rewrite in exponential form. The base of the natural logarithm is e. Therefore, we rewrite by taking e and raising it to the 3.5 power, setting this equal to the argument 2x plus 5. Because of e being irrational, let's solve for x first and then go to the calculator at the very end. To isolate x, we subtract 5 and then divide by 2. When you take this to the calculator, make sure to put parentheses around the numerator since it's a binomial. The base of the logarithm here is 10. 10 raised to the 4.1 power is set to 2x. We isolate x by dividing by 2 and again estimate this on your calculator. Thank you for listening.